Okay, I hope you're having a nice conference so far, and you made it until now. So welcome to my talk. Today I will talk about chaos engineering. A few words about me. My name is Yara. I'm a DevOps specialist at ZUI. I'm passionate about a lot of cloud-native technologies, but Kubernetes and containers are my focus. ZUI is an IT consultancy company. Our headquarters is in Stuttgart, but we have a lot of locations around the world. So ZUI is short for 0, 1, infinity. So we always start from zero. We start early to also embrace technologies and cultures and mindsets, even in their early stages. That also includes chaos testing. So this is the agenda about today. We will talk shortly about chaos engineering in general. What does it mean? Understand how it works. Then how can we actually think about our chaos experiments or chaos testing? Then we will look at the ways on how to actually integrate our chaos experiments in our workflow. At last, we will take a look at some of the open source tools that allows us to run chaos experiments on top of Kubernetes. So, we will transform our monolith application into a microservice. How many of you have heard this before? Quite a lot. So it's actually a direction in the recent years. A lot of companies, especially the ones who have legacy applications, are trying to switch their applications into a microservice architecture. Of course, it comes with a lot of benefits and features. So through your journey, when you try to switch to such an architecture, what you would actually do is you start by breaking your application into small pieces. And then you would take every piece and put it as an independent or a separate service. Ideally, you want your microservices to be as independent as possible, as decoupled from each other as possible. So in case one of them has failed, it shouldn't have a major effect on your system. So you've broken your application, you've transformed it into a microservice architecture. The next step would be to actually distribute it. So you want to deploy your services. One of the best ways to do that, of course, is to containerize your microservices and put it on top of Kubernetes or on a distributed system. However, there are two main problems with that approach. The first would be, with that, there is a certain level of complexity. So there are a lot of moving parts in your system at the moment. And if you try to ask someone who has transformed or who is working on a company that transformed their application into microservice architecture and ask them how many microservices you have, the answer you would usually get is about 100 or something similar. So the fact that you have someone who actually understands the system as a whole, how the whole system behaves together, becomes harder because yes, you have broken your application, but there's a lot of connections, a lot of dependencies, and especially if you have a legacy or a part of your application is still on a legacy system, then the overall behavior of your application becomes not fully expected. So then integration and unit testing become not enough to fully understand how your system works as a whole. So that would be the first problem you face, or you would face, is you want to know how your system as a whole behaves. The second problem is, usually through your journey, when you have broken your application into small pieces and you've built your Kubernetes or your distributed system or infrastructure, you have put so much thoughts in securing your environment. We are always afraid of hackers' attacks that we actually forget about Mother Nature. Natural disasters, so if fire caught a data center and you have a hardware outage or a hardware failure, sharks ate the internet cables and you have a network failure. So there are other failures than just security or hackers attack. So you need to also keep those into considerations. Well, there are several ways to try and solve those problems, but one of the ways to do that, or one of the tools or the mindsets or cultures to do that, is to introduce chaos experiments into your system. So what is chaos engineering? It's simply you're engineering a chaos. You're building a chaos on your system in a controlled manner so you can understand or build trust that your system can actually survive those failures. So instead of waiting for those events or those failures to happen, you're actually doing them yourself to your environment. And just like scientists, they are doing experiments to understand the universe. Also, chaos engineers do experiments to understand how a system behaves and work overalls. Werner Vogel said, this is the CTO of Amazon, everything fails all the time. So failure will happen, it's inevitable. But the question is your system actually ready for those failures or not? So there is no system that is bug-free. You will always have bugs or vulnerabilities in your system, but you want to build better reliability of your system. You want to decrease those weaknesses as much as possible. And those are some of the benefits that you get from running chaos experiments. So when you start exposing your system to threats, you see how your system responds, how it behaves, and then you can ideally discover some weaknesses, which means you get to also improve your system, or at least build an incident response mechanism or something similar. Okay, so this is chaos engineering in general. Now we want to actually embrace this, adopt this on a Kubernetes-based environment. What do we want, or what should we keep in mind when we do that? At first, you want to take an overall look at your system, understand how your system works, and based on that, design your chaos. Just one thing, the term experiment, all the testing, or majorly the testing on top, or the chaos testing, is called experiments. So you want to get an overall picture of your system, and based on that, you start to design your chaos. Another very important point is you want to actually engage your monitoring. So what is the target of doing such experiments anyway? So in the end, you want to see or discover the vulnerabilities in your system in order to improve it. And that means you want to have a good observability overall in your system. So you want to engage your monitoring. A Grafana, for example, dashboard can help in that case. All right, so now you have designed your experiment, prepared your monitoring system, then it's time to actually run the experiment. As soon as you run your experiment, you want to start observing how did your system behave? Was the behavior of your system as you expected it to be or not? Then, ideally, as soon as you found your weaknesses, you want to improve it and then repeat your experiments again. How many of you heard of the PDCA cycle? No one? One person, okay, two. All right, so it's simply a cycle to manage a process or a design. It's short for plan, do, check, act. And this is basically the same thing. So you plan for your chaos testing. This is on the left side, when you have designed your experiment and added your monitoring system. And then you do run your experiment, check, observe, see the outcome, and then act based on that. And this is really a very important part, that you want to improve your system. People get caught up a lot in testing that they forget the target of the purpose of that you want in the end to build reliability in your system. So now that you are confident enough that your system is in a good state, it's robust, ideally, you want to start automate your experiment. So you want your chaos experiment to run on more or less an automated manner and get alerted by them. Okay, what are the principles of chaos testing? There are 4 main principles or steps as a methodology of building your chaos experiments that you could more or less apply in any case. The first step would be you want to know what is the steady state of your system. You want to have a sort of a definition, how your system should behave in a steady state. Then you want to form a hypothesis or a theory. Okay, now I know what's the steady state of my system, but what if I introduce this and that failures? How should my system behave? I would assume, for example, my system will still maintain its steady state. Then you can start running your experiment. And there's a very important part here. You want to run real-world behavior, your real-world actions. Do not take the happy path. If your application, for example, expects a global traffic, then use VPN and simulate a global traffic before you run experiment. When you run your experiment, for example, introduce network failure, storage failure, resource max in and out, and so on. Another way also is you could also look at the history of your system, the incidents that happened in the past, and start to design your experiments based on that, that you can rerun or reintroduce those failures again and see if your system can survive them or not. All right, the first step is, now that you've run your experiment, you want to actually see if your theory was correct or not. You want to either approve or disprove your theory. You want to see if your system has maintained its steady state. If not, then maybe define the weaknesses that you've found, and then start improving your system and ideally repeat. Okay, so this is a very simple example. It's not real world. Of course, I wouldn't even run a database inside Kubernetes. So this is just an example, so we can actually apply those 4 steps. The application is a project management application. It consists of a deployment that runs a pod, and this deployment uses a database in the background, which also uses a persistent volume claim. The application is available on HTTPS connection. So the steady state of my application, that it's running and reachable for its users. My theory is that if I start killing randomly instances of that application, it will still survive. Then I will start running my experiment. I will select some random pods, maybe by their labels or so, and terminate them, and see the outcome. Was my application still available or not? And based on that, define if my system have any sort of vulnerabilities. Of course, this is a simple application. Okay, Case Toolkit. So Case Toolkit is one of the open source tools that you can use to run your case experiments. It's pretty simple. So I have prepared a short demo. So, good. So this is actually the application we just saw. We have the pod, which is the project management application, and it's reachable through this URL, pm.ya/playzui.de. And here is my experiment. So at first, I defined my steady state, which is I expect the application to return 200 if I send HTTP request. So this is the steady state prop. Then my action is I want to terminate one pod with a specific name pattern or a label. The pod should be ideally random, and it's in that namespace. So that is ideally or should be the pod that will be terminated. Okay, so in the experiment itself, when I start to run the experiment, I choose to have my health check prop to be checked always continuously. You could also say I want it to be only after I run the experiment. So when I start to run the experiment, the pod was deleted. However, you can see already a warning that the steady state was not met. So of course, because it's one pod only, it won't be available if it's terminated. So I have defined now a weakness of my application that is not enough high availability or doesn't have enough availability. Then the next step would be to improve. So as part of my improvement, I have decided to change the number of replicas to be 3. So I want 3 instances of my application, and I want my application to be available by 75% in case I do a rolling update. So ideally, the pod gets created. The application should also be still reachable. So now the application is running. Now it's time, I've done my improvement. I want to say if it's effective or not. So I would rerun my experiment again. So as you can see, the pod was already terminated, but this time the experiment finished correctly. The health checks props were also returned or tolerated. Okay, so that's a simple demo just to understand how the chaos testing works. Now we know what is chaos engineering. How can we actually integrate that in our workflow? If you've ever heard before about chaos engineering, it would probably be from Netflix. So they have introduced it in 2011. They built Chaos Monkey, which is an open source tool. But Netflix, what they said or what they did was they ran those chaos experiments randomly on their productive system. And it's always the focus or the culture is to run your chaos experiments in a production system. However, there are a lot of other ways that you can integrate your chaos testing through your workflow. For example, during your development pipeline or your development deployments, you could always run some chaos tests. Most of the chaos testing tools provide you with an operator, which means you can also just define some custom resource definitions in your cluster and get your experiments to run as part of your pipeline. Okay, the next would be a testing environment. So, in my opinion, before I just go into in my prod account or my prod environment and just start breaking stuff, I would start first in a testing environment and then start as much as possible to replicate my production account or environment. There are several ways to do that. So you could, for example, record the traffic to your prod application. A lot of ingress controllers can be integrated easily with monitoring system, and then you can see and re-simulate that traffic. So as the resource usage, for example, so you can always use your monitoring systems to see how your environment looks like and then start to simulate that in a testing environment. Then you can start running your experiments, and based on your outcome, you can improve your productive environment as well. The pre-prod environment. So ideally, every change in the infrastructure will affect your overall system. So you want to also rerun all your tests or your experiments as part of your infrastructure pipeline. It would be similar to the development lifecycle, and it's not only infrastructure. So also every new application deployment. So also changes in the application as well. At last, if you are comfortable enough, if you're confident enough that your productive environment is reliable now or robust enough, then you want to start introducing chaos testing in your productive environment, and you could make it as random as possible and get, of course, alerted with the outcome. However, there are 2 points that you want to keep in mind in that case. The first would be, how do you know if the alert you have received is actually an experiment or an instance that you want to respond to? You could do that with several ways. So for example, you could have a pre-hook that labels your experiment group. So select randomly part of the prod environment as your experiment group, label it that this is going to be used for experiments. So when you get the alerts, you would know that this is actually just testing, not a breakage in your environment. The other one would be, what if things get out of control? So maybe in your experiment, you break something very sensitive. Of course, it's a great opportunity to improve your system. However, you want to always have the emergency break button. You want to always know how to just stop your experiment. Also, a great approach is to have a rolling back strategy. So at the end of your experiment, you want to roll back everything to how it was. So for example, if you've made changes to a deployment, you want to roll that back. If you have deleted something, you want to redeploy it again. So the last point, open source tools. There are a lot of open source tools that you could use on top of Kubernetes. I've chosen 3 of them to compare. That would be Litmus. This is more or less a fully platform. It includes a lot of capabilities, like analytics, for example. So it's not just for running experiments. Chaos Toolkit you've already seen. It's pretty much a simple tool, but it contains quite some good experiments. And Chaos Mesh is actually built for Kubernetes. So those are partially some points you would want to look for when you are choosing a tool for your chaos testing. For example, how many experiments does the tool contain? So the bandwidth of the experiment. It could be, for example, like Litmus. It has a very large experiments. Chaos Toolkit is a little bit less. Chaos Mesh is one of the tools that have also less experiments, but they are different. So it has more or less a unique attack range. Another thing to look into is the schedule. So can you actually have a built-in schedule in your tool or not? Can you run it continuously or not? Litmus supports that. Chaos Tool Mesh, not so much. It's a little limited. So it's more or less through a cron job. Also the web interface. So whether your tool provides a web interface or not, I think for Chaos Toolkit there is a paid service that you could use, but natively it's not in place. Chaos Mesh has integration with GitHub Actions, so it can easily integrate with your pipelines. Another thing is the health check props, that the one you saw in the demo before that I checked, for example, for HTTP requests. There are a lot of other health checks props in Chaos Toolkit, but not every tool has this. So if a tool like Chaos Mesh, for example, you would want to include or integrate another monitoring system that does those kind of checks for you. Okay, another point is the cloud providers. So mostly we do not run just Kubernetes. Most of us have a lot of dependencies around it. So you want to see if the tool has a driver to check for other resources in your cloud environment or not, whether the tool have a cluster operator or not, how does the logging and reporting looks like. In the demo we saw before, we could see a report of the outcome. Some other tools doesn't have this or have it in a limited way. So which one to choose? There's no one solution that fits all, but if you want a simple tool that you could run some tests and can cover some range of tests, then I would go with Chaos Toolkit. However, if you want a more fancy solution that have a lot more to provide, I would go with Litmus, although it has quite a high learning curve. Chaos Mesh is good performance, but it cannot provide every function alone, so you would need to integrate other tools around it. So, a short recap about what we learned today, or what we understood today, hopefully. Chaos engineering, the mindset or the culture itself, its principles, how you can design your chaos, what's the importance there, and the most important part is actually the target of chaos engineering. So what do you want to achieve with that? A lot of people and also tools just focus on the tests, the attacks, how we will break things. It's fun to break things, of course, especially in a productive environment, but there's a target of that. You want to improve your system afterwards. Don't just run your chaos tests and then put the outcome in your backlog tickets and just leave it there for a year or two. You're not getting the benefit of actually spending the effort and time in that. I hope I got your interest in the topic. If you want to get started or get familiar with it, I would recommend Chaos Toolkit. It's pretty simple. Doesn't need a lot of setup in the cluster. You can just have the CLI locally and get yourself familiar or start with it. If you have any questions or interesting discussions, I'll be around. The demo I showed before is live, and there's also Chaos Mesh in the same cluster. So if you want to play around, just come to me. For the people who are joining online also, feel free to get in touch with me if you have any questions. I wish you a nice conference. Thank you.